So, good afternoon, everyone. Welcome to ABBI featured speaker seminar. So, my name is Kaori Hitori from ABBI, and I will be moderating today's session. Thank you for joining us from across Asia and beyond. Today's webinar, Economics from Outer Space, leveraging satellite data for research and policy, is jointly organized by ABBI in collaboration with the Global Development Network. So before we begin, a few quick housekeeping notes. So for those joining online, so you are muted by default, and we encourage you to submit questions throughout any time during the webinar using a Q&A function. So the session is scheduled for 60 minutes, but we will allocate Q&A session so that you can ask questions to Professor Arcand. Accurate and timely data remains a major challenge for development research and policy making, particularly in low and middle income countries. Traditional data sources often struggle to capture fast-changing economic realities at a granular level. Recent advances in remote sensing and satellite data, however, are opening new possibilities for measuring economic activities, urbanization, energy use, and broader development outcomes. Today's featured speaker will explore how these tools can help bridge data gaps and support more informed and inclusive policy decisions. It is my pleasure to introduce our featured speaker, Professor Jean-Louis Arcand. Professor Arcand is the president of Global Development Network. It's an international organization founded by Nobel laureates Joseph Stiglitz to strengthen social science research capacity in the Global South. He is also professor for international economics at the Graduate Institute in Geneva. Professor Arcand holds a PhD from MIT, MPhil from Cambridge University, and a BA with high honors from Swarthmore College. His research spans development economics, impact evaluations, health, mathematical economics, and political economy. He has consulted extensively for international organizations, including the World Bank, UN agencies, and the Gates Foundation. We are delighted to have you, Professor Arcand. The floor is now yours.
Thank you. He's saying something like unmute or something on my screen. Sure. Okay, that's gone away. It's gone away. Someone else is in control. You're in control of that, right? Yeah. Okay. Okay. So I'll try to be relatively brief. So don't worry. There's a lot of slides here, but I'm not going to use all of them. I'm going to skip over a bunch of them. So how long do you want me to speak for?
30 minutes.
Okay, perfect. No, which is perfect. So we have time for Q&A. No, perfect. So at some point you have to say time out.
Yes.
Okay. Like, go away, shut up. I'm an old-fashioned micro-development economist, just so you know where I'm coming from. So a very sort of kosher, halal, micro-development economist I've done, I think, something like 27 surveys in the field from places from Haiti to the Philippines to Pakistan to you name it. I mean, and mainly Africa. I'm mainly in Africa because I'm born in the Cameroon. My passport says I'm Canadian. And a few years ago, I started. This was when it was actually something new. So this is almost 15 years ago. It was around 2012. Started working using nighttime luminosity data, and I fell in love with this data. And what I'm trying to communicate in this presentation today, and I'm certain there are people in the room there's some young punks in the room, especially, who know a lot more about this than I do. But I want to communicate my love for these data and how important they can be, especially for researchers in the global south. We're resource constrained. I think that the value of the Lagrange multiplier associated with that constraint is huge. in the sense that a very small amount of funding to train researchers in the global south to access remote sensing data, in particular NTL, because the data itself, they're free, right? But there's a fixed cost. And at some point, maybe GDN and ADBI can partner together to try to figure out a way how to diffuse this know-how more broadly in the global south. Anyway, the economics from outer space, I like the title. You all know this picture, right? This is the standard picture of our planet. And economic activity is highly associated with nighttime luminosity. There are various sources of data. So again, some of you probably know a lot more about this than me. The old-fashioned data. This is Tunisia, by the way. I've worked a lot in Tunisia in the past. This is sort of showing a 3-year change. You can see it's sort of blurry. This is the old data. Okay, this is the old data where the resolution is fairly poor. The black marble data. For those of you who don't know anything about NTL, I'm just going to say NTL, nighttime luminosity. You go for black marble. Okay, that's the best data. As long as the American administration doesn't shut down NASA, but hopefully they won't. Or get rid of that section. What you can see fairly clearly now, the resolution is good enough. You can see in a 11-year period, you can see the economic growth of Tunisia, like it's nakedly to the eye, right? You can just see how it's becoming around Tunis and around Sfax and around Gavis. You can just see Gavis is the yellow thing on the right to the further side. You can see how, sorry, no, that's actually Sousse, sorry, and how it's getting more developed. And you can see the island of Jerba getting slightly more light. You can track aggregates using NTL. So this is basically, and I'm not going to bore you with the unit of measurement of NTL. It's something per steradian per it's a horrible unit. Okay, it's a real mouthful. But you can track. I'll be using this later. You can track aggregate economic activity also in terms of NTL. So I'll show you some other examples. This is for Tunisia. So this tracks GDP of Tunisia really well also. I'm going to skip over these. These are the various types of these are the VIRS data. So you have data going back to 1992, but the resolution is really bad. That stops in 2013. And then basically the good data starts in 2012. So you can look at stuff starting in 2012 with some fairly good data. This is New Delhi. It gives from 2012. It gives you how good the new data are with respect to the old data. By the way, data is a plural in Latin and in English. It's actually datum, data. I know the singular is datum. This is one of my pet peeves. It drives me crazy when people say the data is. No, they are. It isn't. They are. But anyway, it's a losing battle. This is also there's all this stuff, the VIRS and the NASA Black Marble. So NASA Black Marble is basically an evolution of the VIRS. The algorithm is fabulous. You can read up all about this if you haven't done so already on the NASA website. So the literature, for those of you who don't know the literature, the seminal paper is an AER paper in 2012. Then there's already in 2016, there's a JEL review article. And even as conservative an institution as the International Monetary Fund that now uses NTL as a measure of economic activity, especially in Africa south of the Sahara, where data is particularly poor. And then there's various web resources. I can leave you, but obviously I'll leave you the slides for those of you who want to go and look at the data. The GitHub is really good. And so all sorts of, if you're an R user, you use R and Python, everything is up there. They're like online courses and everything. It's really good fun. Anyway, so I'm going to give you 3 examples. Okay, I'm going to give you 3 examples of the use of NTL. So this is Morocco. When you look at those 2 pictures 4 years apart, it's difficult to tell, right, whether there's been a change. There actually was a lot of change during that period. And what you have to realize is that when you're looking at NTL data, this isn't a new methodology. This is just another source of data for measuring economic activity. And the pixels, well, they come at different levels of resolution, but your unit of observation is a pixel. So if your index is IT, I is the pixel, T is the time period, whatever it is. You average it over a year, you average it over a quarter. Is it total saturation? Is it average saturation? I'll show you examples, different examples of this sort of stuff. And interrupt me, by the way, at any point. This is showing you at the macro level, using quarterly data in Morocco, how well log NTL tracks log GDP. Okay, and you can see it works pretty damn well. Generally, in time series, you're going to get R squares of like 0.8. Sometimes it's higher, but it's it looks as if I cheated. I'm not cheating here at all. This is what the data look like. I'll give you some interesting some other examples of this a little later. And this is in cross section. Okay, so this is basically taking the Ashimogu Johnson Robinson data set of former colonies. So I showed you time series for one country. This is the cross section where you have log GDP per capita in PPP in 2016 on the horizontal axis, and you have log luminosity per capita. Okay, and as you can see, the fit again in the cross section in the Ashimogu Johnson Robinson data set is pretty damn good. So the thing, of course, it's just another source of data. So whatever your identification strategy is, whether you're doing an RCT, whether you're doing an RDD, whether you're doing diff, whether you're doing IV, it's just a great outcome indicator. Nothing changes in terms of your identification strategies. It's just another source of data. Because sometimes people say, this is a different methodology. It's not a different methodology. You're just applying standard econometric methodology using a different source of data. So I'm going to start off with an example of impact evaluation using this. So the INDH, Initiative Nationale de Développement Humain, so the National Human Development Initiative, was what His Majesty King Mohammed VI of Morocco defined as his chantier de règne, so the work program of his reign. And Morocco's a big country, but they put basically $1 billion into the first phase, $2 billion into the second phase, and $4 billion into the final phase. So I was intimately associated with the Prime Minister's office with the impact evaluation of this program. And we did surveys. We did some wonderful, we had 1,600 households that we surveyed 3 times. At 18 months intervals, so beautiful panel data. Any micro development economist such as myself, that warms the cockles of our heart. It's exactly what we live for, is panel data. But at the end of the project, I was getting into NTL. So I started this project with the Moroccans in 2007. Towards 2000 and I think it was 2015, I said, why don't we try NTL on this? Why don't we try nighttime luminosity? And why don't we write a 2-pager for His Majesty the King? So the reason I use this title, Economics from Outer Space, is that the note that I produced for the Royal Palace was called l'INDH Vue de l'Espace, seen from space, the National Human Development Initiative seen from space. They call it the National Human Development Initiative. This is a footnote, just so you understand Morocco, because Morocco keeps on slipping down the Human Development Index. It's a national obsession. And so I have, government ministers asking me, how can we get back up? I said, well, forget about the Human Development Index and just no, it's a national obsession. So this was a really pretty program, really, really, really pretty. So Martin Ravalian, the late great Martin Ravalian, from the World Bank, had just been in Morocco in 2004, and it helped them construct at the HCP. The HCP is Haut Commissariat au Plan, so the High Commission for Planning. That's actually the statistical agency in Morocco, and they've done a poverty map. Perfectly done poverty map. And the way in which the rural component of the program, they decided to deploy it. So rural communes, so rural Morocco is divided into rural communes, something which is common in a lot of Francophone Africa. In Anglophone Africa, it's sort of like a ward, something like that in rural areas. They decided that rural communes which had a poverty rate in 2004 above 30%, so the headcount poverty rate, would get the program. If it was below, they would not get it. Okay, so if you have a poverty rate of 29.999%, in 2004, you do not get the program. If you have a poverty rate of 30.001, you do get it. A few communes below the threshold got it because there was lobbying by the Wali, etc. That's not a problem in the sense that all it means is it's what's known as a fuzzy RDD. But this is just like RDD, conventional impact evaluation using RDD on our household survey data, but why not do it with NTL? So, which is what we did. And so you get this really nice picture. Okay, I love this picture. And what is there a pointer on this? I think there is, but it probably no. Okay, I didn't know if there was a pointer. Sometimes there are pointers on these things. Ah, there is. But of course, the people online cannot see this, so the people in the room can see it. So you see here. So what we have here is this was the report for the king. That's why it's in French. The forcing variable is the poverty rate in 2004. Okay, the unit of observation is a rural commune. So 0 here, it's the poverty rate. That's 30% poverty rate. That's a 40% poverty rate. That's a 20% poverty rate. That's a 10% poverty rate. Okay, and that's a 50% poverty. No, it doesn't matter. Okay, so that's what we have. So that's something which is time invariant. Okay, for each rural commune. And then on the vertical axis, what you have is the saturation in terms of NTL, the average saturation. Well, actually, no, it's the average saturation of that rural commune. So you just simply overlay, the shapefile, the administrative shapefile. And of course, there are different values for a given rural commune because it's in different years. And this is over like a 10-year period. So it's completely standard panel data, right? Completely standard panel data. And as you would expect, when you run a non-parametric regression, okay, you see the curve here. So you run a non-parametric. Whether you do this with a local linear regression or the fancy gizmos that our statistician friends have, which are a lot more sophisticated than what we usually do in economics, you get a downward sloping relationship, right? Because nighttime luminosity, the higher the poverty rate, ceteris paribus, the lower nighttime luminosity, right? So that's why you get that downward sloping non-parametric smooth. And the impact of the program is exactly at that threshold of 30, of the 30% poverty rate. And the jump here is 19%. Okay, 19% and this is like, the T statistic is like 1.9. Okay, so you get a nice, tightly estimated increase in nighttime luminosity of almost 20% attributable. Nothing else was going on. I'm not going to get into all the stuff that you have to, the placebo regressions and everything that you do here. Standard Lee and Lemieux type RDD stuff. And this costs 0. You do the impact evaluation of a program. The cost is 0. Okay, simple as that. That I find is wonderful. Okay. Now, you can't do this for every program. Not every program is visible from space. Okay. But when it's rural infrastructure, it's that well visible from space. Okay. So that's first example. You have questions about it, I can go further into this. Second example, big picture macro. Okay. Like what's two of the most celebrated papers, over the past 20 years, Hashimoto, Johnson, Robinson. Let's take the 2002 QJE reversal of fortune. You could also take the 2001 AER paper. You take your pick. Okay. So what I just want to show you is, so you remember in the 2002 QJE paper, you have the reversal of fortune, right? So this is I'm a micro person, but I kind of appreciate it. I'm sort of more like Vermeer. This is sort of like this is cubist. Right. This is definitely impressionist. It's actually cubist. It's sort of okay. All countries that were poor 500 years ago, all former colonies that were poor 500 years ago are rich today, and all that were rich 500 years ago are poor today. That's the reversal of fortune. And then they explain it through their usual really weird institutional variable. Right, protection against expropriation risk. You talk to a political scientist, they go away laughing. Okay, and most of my political science friends actually go away laughing. Not Jim Robinson. He sold this very well, but it's a really weird measure. I have an alternative identification strategy for that, but no one cares about this stuff anymore. So it's the famous settler mortality variable. Okay. Anyway, what we did here. So this is work that's actually ongoing. It's sort of a pet project of mine with one of my former PhD students who now works at the World Bank. We use this whoops, the wrong thing. Sorry, guys. We'll come back here. We got this high data. So these are some crazy Dutch researchers who basically construct data with all the caveats, right, that should go along with it on land population and built up areas going back to 10,000 BC. Okay, so it's worth what it's worth, right? And I've worked a lot on colonial statistics. My instrument is actually the proportion of the native population, though. It's not mortality of white settlers. It's the proportion of the native population that was killed during the first 100 years of colonization. Okay, that's the second equation. Then I need the third equation because that's endogenous. Okay, and then it's actually geography, which is going to be explaining the proportion of the native population. I can't get this to fly because no one cares about this crap anymore, right? But it beats. Okay, I have a paper where it beats actually the HAR instrument, the settler mortality in a horse race. It wins anyway. So let me show you. I find this is kind of fun. So I'm not going to show you the standard reversal of fortune paper. Okay, you basically do a regression where you have GDP per capita today, okay, of a country. You regress it on a measure of GDP per capita, a proxy for GDP per capita 500 years ago, okay, which usually is an urbanization rate, something like that. And okay, that's the standard HAR thing, and you get a negative coefficient, right? The coefficient is negative. Okay, so this is taking it first, doing it at the 1.6 arc minutes degrees resolutions. Okay, so there you're talking instead of 100 observations or the standard 61 observations of HAR, you're talking about something like 8,000 observations. Okay, and then that's the left-hand map. I'll explain what it shows. And then to the right, you have like 1.3 million observations. So it's subnational, right? The unit of observation is a pixel. Okay, and my proxy for development here, our proxy with the Pinyi Chen, this former PhD student of mine, our proxy is basically its population, its population density in 1500 as measured by that. We have measures of population, then we have measures of actually no, sorry, let me remember. No, it's a land measure. It's a measure of arable land in 1500 at the pixel level. Okay. So with lots of noise. Okay, this is if ever there was measurement error, there's measurement error. So what you have on the left-hand side at the more coarse resolution. So this is a geographically weighted regression. Okay, so it's like doing a non-parametric regression, but at the spatial level. Okay, so when you have here on the left, when it's red, the coefficient is negative. Okay, so that's reversal of fortune. When it's blue, the coefficient is statistically significant and positive. So you no longer have the reversal of fortune. Okay, so the reason I'm showing you this because then you see the next thing. So this is where you have 1.3 million observations instead of like 61 observations in the HAR paper. Well, you can see that there's a huge amount of heterogeneity. Look at the U.S. Okay, for the U.S., Eastern U.S., I thought that it was going to be north-south. It turns out east-west. I have no explanation for you have to go country by country by country. I'll show you another picture in a second. You can see that in some places there is reversal of fortune. In other places there is no reversal of fortune at all. So all I'm showing you is simply the fact that this is what people in ecology call an ecological fallacy, right? Depending upon your level of aggregation, when you aggregate to nation states, you get reversal of fortune. When you go down to 1.3 million pixels for these countries in the world, you no longer get a reversal of fortune. You get all sorts of heterogeneity, even within countries. And I find this interesting. And I'll skip this. Anyway, then we really went down to looking at very detailed data on the US and Mexico. And we were looking at the institution of slavery and trying to see if there is a reversal of fortune. And what you can basically see is that in Mexico, you do not have a reversal of fortune, especially for slave states. Anyway, we have a long discussion of this. I'm not going to get into the details. So that's sort of big picture, macro, Cézanne in terms of painting, right? Sort of and we're taking the Cézanne and we're making it more pointilliste, right? It looks sort of more like it's pointilliste. Third application is policy analysis and like rapid policy analysis. So I was professor in Geneva for 15 years. I'm leaving the Graduate Institute. Don't get me started on why. I'll get in trouble. So when you're in Geneva, so I have one of my PhD students happens to be Palestinian. And anyway, it's a long story. So I did a lot of consulting work for the Palestine unit at UNCTAD. And one of the things that occurred to me, so we started already doing stuff with UNCTAD on we started doing stuff on various issues in the occupied territories and some very interesting stuff that you can do. We started using NTL. you may recall some small events that happened in October of 2 years ago, okay, when there were these attacks, the Hamas attacks on Israel, and then the Israeli military, subsequent Israeli military operation. And by January 2024, we'd already used nighttime luminosity to assess the impact, the economic impact of the Israeli military operation on livelihoods in Gaza. And the only way you can do something like this, especially if you're in a war zone, is to use NTL. I mean, apart from the fact that I have already had, I'm old enough to have had 2 survey workers killed when they were working for me, and I'd never want to have that ever happen again. So you can't send people into Gaza to start collecting household data. And if it's the Israelis doing it, the Palestinians are not going to believe it. If it's the Palestinians doing it, the Israelis are not going to believe it. This is, for the time being at least, our American friends, for once, are providing a global public good. Not many of those that they're providing anymore. But this is a global public good. It's completely neutral. It's costless, and no one gets killed. Okay? So actually, we already 3 weeks after October 7th, we already had a first version of this paper. Okay? So we did a quick and dirty thing, but it took us 2 days to code this. It took us 2 days to code it. So then we started working on it. And now we have a paper which has just been accepted in proceedings of the National Academy of Science, Nexus, and FAST Nexus. So that I'm really happy about. Collaborating with some other colleagues who were real experts in SAR. Anyway, so how do we proceed? So the first thing is you basically have maps of pre-conflict built-up area. Okay, so these are very detailed maps. They're at very, 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 very fine level of resolution, and they're free. Okay, so you can see, if you look at the left-hand thing here, that's Gaza City detail. This is like 10 by 10 meter resolution. All of this is free. Okay, all of this stuff is free. It takes a little bit of work, or just get associated with a geek who does GIS, right? Geography people, they're really good at this stuff. Okay, so you basically, it's been used for earthquakes. Okay, it's very useful for earthquakes. It allowed us to systematically map at a daily level. Actually, we have the data at the daily level. Then we aggregate it up to the weekly level. But however we aggregate it temporally, we always get the same result to the 40 by 40 meter level. Okay, so that's our initial pixel in terms of damage, because it's basically a change of the surface terrain. Okay, and you can read up on all of this in terms of the techniques that are used. I'll pass that. This is a map of the damage during the first year. This is from October 2023 to October 2024. Okay, and so this is the Copernicus satellite. This is a European satellite. This is not American data. This is European data. Okay, and it's just as good as the American data. But that for destruction, what you see on the ground, if you're working on earthquakes, these are the data that people use. These are the data that you should use. So we aggregate this up to 1 by 1 kilometer grids. Okay. The reason you do that, some of you who like to do spatial econometrics, you've probably read Morgan Kelly's, the standard errors of persistence. Just as you get, you have a Durbin-Watson for serial correlation, well, you have exactly the same statistical formula for spatial correlation. Okay, and you regress spatial noise on spatial noise, you will get something which is statistically significant. Okay, it's the same thing, same problem as with uniforms. Okay, exactly the same thing. So you want to aggregate it up. Okay, because you basically can filter out a lot of the spatial correlation. Then you have to deal with the spatial correlation matrix, but we aggregate it up to 1 by 1 kilometer grids. Okay, and so you can see there's a lot of heterogeneity in terms of the destruction on the ground in Gaza. You have places where when it says 92.4, okay, when it says that means that within that grid cell, which is red like that, you do the math. 1 kilometer by 1 kilometer. Okay, the original grid cells are 40 meters by 40 meters. So you do the math, how many do you have? 625. Okay, so that means that there are places here where out of 625 grid cells, there's like 600 have been essentially destroyed. Presumed destroyed. Okay, that's the terminology that you use. This is all satellite observation, but the stuff that people are getting really good at that. Okay, so you can see there's a lot of heterogeneity in terms of 33 grid cells everything, 100% has actually been wiped out. That was in the first year. So how do we get economic activity? We use NTL. Okay, we're using the standard black marble package. We aggregate this up basically to the same 1 by 1 kilometer. This is the change in nighttime luminosity. This is the same grid as what I showed you for the damage on the ground, for the disruption. So what you have on the left is basically an average of the 2 weeks before October 7th of 2023. So this is basically September 2023. What you have on the right is 1 year later. It's October 2024. And as you can see, most of Gaza has gone dark. Okay. Most of it has gone dark. Of course, we have weekly pictures like this for every week in between there, for the 52 weeks in between. Okay. So this is standard diff econometrics. Now, of course, my co-authors and I, at least 3 of the co-authors, we are card-carrying economists. So you got to let us sort of use some sexy econometrics, right? So we don't just do standard diff, okay? We use the Callaway and Santana. This is remember the thing in the Journal of Econometrics, the special issue of the Journal of Econometrics 4 or 5 years ago, where all the new diff, papers came out. And then, given that we're really geeks, we did the Callaway and Santana with, all sorts of machine learning, double machine learning and things like that. And anyway, so we had a lot of fun as geeks. That's what takes time. And this is the impact of the conflict. Okay. So what you have before, and this is for the various, you can see whatever estimation method we use, those are the solid or dotted lines. We get the same thing. The colored things are the 95% confidence bands, basically. And what you see is that, so the first ones, so the ones which are over here before, that's not elaborating. There we go. Yeah, screens are bad for this. So this is October 7th. Okay, that's where the conflict started. So those are placebo regressions to the left of that, right? If anything was statistically significant there, you can see it's centered on 0. Okay, so our placebo regressions obviously don't show any effect, right? Which is what, alhamdulillah, that it doesn't show any effect. And you can see that it's basically during the first month you get the first wallop. That's where you get the marginal effect is really big in the first month. Then you continue getting people who study conflict have seen this picture many times before. What's interesting here is that we can quantify it, and whatever method we use, más o menos, we get the same result. Now, what does this end up meaning? So there's 2 ways in which we did this. So what is the reduction in NTL? So on the left, what we have is what are known as localities. So PCBS, the Palestinian Statistical Authority, divides both the West Bank and the Gaza Strip into things called localities. It's like a municipio, right? So that's basically what it would be. So Gaza Strip, there are 33 of them. And you can see the heterogeneity. The right-hand picture is what the Israelis refer to as evacuation zones, okay, which is another way of that's the sort of the military divvying up of the Gaza Strip by the Israelis is evac zones, and localities is sort of the standard Palestinian disaggregation. And you can see how disparate the things are, right? You have places where basically you've had a fall of here, like 41% in NTL. But you have places where you're an 80% fall in NTL. Okay, so 80% of nighttime luminosity. That's the treatment effect. That's the treatment on the treatment, estimated with all of our gizmos. And so this has to do with the damage intensity. So it's not exactly surprising that it looks similar to the picture I showed you before. These are various ways of measuring the multiple damage rounds. For those of you who are interested, send me an email. I can send you the paper, which was just accepted at the proceedings of the National Academy of Sciences. There are all sorts of threats to identification. We have to discuss this in terms of electricity. I'm not going to bore you with that. Yes, this is interesting. So now we have the fall in NTL, in nighttime luminosity. How do we translate that into GDP? Okay, because who cares about nighttime luminosity, right? Okay, the lights are up, but I want a dollar measure, right? And if the international community has to put together a package to rebuild Gaza, they want a number, right? The World Bank wants a number. European Union wants a number. Our American friends, in theory, want a number. So we did this in 2 ways. We did it time series. So remember I showed you a picture of Morocco where you had the GDP tracking the average level of NTL. We can do that here because PCBS, but it's 43 quarterly observations. Okay, so there's not a lot of information in this. So what we also did, this I really like, is we constructed a poverty map of both Gaza and the occupied territories. We constructed a poverty map. Hopefully everybody here knows how you construct a poverty map. You basically have to have household survey data and the full census microdata, right? And you estimate basically a model of, in this case, it's expenditure per adult equivalent, okay? Expenditure per adult equivalent as a function, using the household survey data, as a function of the small set of variables which are common to the household survey and to census, okay? You get the coefficients, and then you simulate using the census data. You simulate, and you have a standard error, so you can correct for measurement error and everything because it's a generated variable. You can calculate basically the household expenditure per adult equivalent for every household in Gaza and in the West Bank. And so then you aggregate. Okay, these are all georeferenced, every single household. You can aggregate them to the pixel level, and then you aggregate it to the pixel level, and you correlate that with nighttime luminosity at the pixel level. So that gives you a cross-sectional estimate of the exchange rate between nighttime luminosity and household expenditures per adult equivalent. Okay, so it's an alternative way of doing it. There's a literature on this, by the way, as some of you probably know. Sometimes there are big differences that you find when you're using time series versus cross-section, okay? We basically find an elasticity between 1.1 and 1.2, however we do it. It's completely robust. This is not true in every country in the world. For some countries, there's significant nonlinearities, by the way. It's a monotone relationship, but there's significant nonlinearities. But we're lucky enough that it's extremely, and this was the time series stuff. Oh, and just one last thing, and then I will be finishing. Back here, that I forgot to tell you, there's this really cool result. I mean, not cool for the population, it's here, but just cool in terms of how. You may remember in November there was a ceasefire. In November 2023, there was a 1 week ceasefire. During the ceasefire, nighttime luminosity goes up by almost 9%. Okay, so that really tells you that the NTL. This is not a fluke. It really is measuring economic activity. Ceasefire, boom, as you would expect, economic activity goes back up again. And let me just show you one last picture here, which was, okay, so this is converting it using poverty mapping. So the PECS is the standard household survey. We have the two censuses. Those are the two census years, which are 2007 and 2017. And so this is basically everything translated. It doesn't change much when I do it non-parametrically, also to allow for the nonlinearity of the exchange rate between the two. So this is sort of the final thing. Again, we have all this code. The code, by the way, all our code is available on GitHub. Okay, so you want our code. You can wait for the PNAS paper to come out from the GitHub code. The data we can't share because we'll get in trouble with the Palestinian Authority if we can't share the micro data, so you can't redo all the poverty mapping. But this basically gives you can see that basically you have a 75% loss in household expenditures per adult equivalent. And when we sum up the cost, okay, the cost of 1 year of the operation in terms of household expenditures, it's a fall of 2.6 billion. That's just for the Gaza Strip, okay? That's really small. That's just the direct cost in terms of lost economic activity. So actually, we can give you a number, okay? So the UN wants me to give them a number. The number that we give them is 2.6 billion for that 1 year. And this, I find, it's a really useful use of data. So the three examples, hopefully I've convinced you. If you haven't used, some of you have already been converted to NTL, I'm sure, and are using it much more productively than I can. But I thought it was worthwhile showing you three examples which are completely different. The last one was really sort of instant economic policy. And I'm actually, I have the good luck that the Minister of Economic Development in Benin wants to set up a unit within the ministry to harness NTL data to follow the development of Benin in a systematic fashion. I think that could be money really well spent if we can go out, GDN and ADBI together, if we can go out and we can convince some funder to help us set up units in prime minister's offices or I don't know, or Ministry of Finance, I don't know, in a bunch of countries, I think that the payoff to that kind of investment, you need two people basically doing this. Okay. You need and two people with authority to back them up. Okay. Because you need one person who's a geek who knows all the GIS data. Okay. So you need geeks. You probably need several geeks, but then you get students from the statistical school of the country, right? They're dying to do this sort of stuff and they get to write their master's theses, using this sort of data. And then you need basically someone who also is from the statistical side who has access to the census and has access. And then you need the policy people to feed in information on what programs are going on. But you can follow stuff without having to do surveys. And for me, every prime minister's office should have a unit like this, which follows economic policy. But as I showed you, you can also do it for big questions like AJR, and you can also do it for very prosaic causal estimation of impact evaluation. I like RDD. I'm not anti-RCT. It's just that I'm sick and tired of sort of the JPAL version of the world. You guys do smart RCTs, so I definitely like what ADBI does in terms of RCTs. But that's just NTL. I know you can't probably see this on the screen, but there's so many different sources of remote sensing. I don't have the imagination to use all of them. You probably do. And I've done stuff on conflict in the Sahel region with people in Burkina Faso on this. And all of this is certainly not me alone. So these are all, apart from the last guy, those four people I've had 74 PhD students. And counting. That's a lot of kids, 74 PhD students. And I have grandchildren because I have my 74 PhD students, they've had PhDs. Yeah. I'm about to have a great grandchild. So one of the PhD students of my PhD student, her PhD student is about to finish now. And so the only thing on RepEc where I have a decent score is strength of graduates. I'm like in the top 1% worldwide for strength of graduates because I have 74 kids, right? A lot of these people. And so Pinyi is Chinese, she's at the bank. Rami, he still works, he's Palestinian, he works at UNCTAD. Hamid Reza just defended, he's Iranian, he just defended a month ago. And Daniele Rinaldo, so I'm saying this on a webinar, but so people will hear me, my 74, he's the best. But the others know he's the best. They're not gonna complain. He's brilliant. He happens to be a concert pianist too. He has 2 records out. Some people get very large initial endowments, as people in general equilibrium theory would say. And I'll stop there, and I'm sorry for running over time.
If they are not here joining live, we can show you the recording will be available on so please subscribe. Anyway, so here we are gathered with all the researchers and the associates colleagues as well as the inbound. So should you have any questions? One question from Ari.
Thank you very much. It's a very enlightening and informative presentation. I like it a lot and I learn a lot as well. But I just have a question on how do you deal with noises when you look at the night lights for Palestinian area in Gaza?
How do you deal with
the noise? How much cloud do you?
Oh, the cloud stuff. I mean, these satellites are circling all the time. Black marble corrects for cloud, snow, gas. This is not a panacea. When you get into so it's actually surprising in some sense that it works for Gaza given the population density. But if you were looking at Tokyo, it would be useless, right? It's completely saturated with light. It works in a developing country context. So this is definitely a technology which is global south friendly, but it's not a panacea. It's measuring things with error. But when you look, for example, in the cross section, when you look at household expenditures per adult equivalent aggregated at a pixel level or aggregated for the case of the occupied territories in Gaza at locality level, and you correlate that with nighttime luminosity, you get an R squared of like 0.8. Again, it fits really well.
You're correlating a survey that comes.
Yeah, basically, I'm constructing. So I take I do poverty mapping.
Yeah.
Okay. So I an estimated measure of household expenditures per adult equivalent
Right.
for every household. Then I can aggregate
At one point.
at one point, yeah, at one point,
And
yeah.
then you connect it with the
Yeah, exactly.
series of night lights.
And then I take an average value of night lights, aggregated in the same way, either an administrative district, and then I basically have, so, of course, we're economists, right? Assume a
Right.
can opener.
Yeah.
Right? So there's a lot of assumptions underlying this, but it's a useful tool. It's not
That's
the only
right.
tool.
That's
It's every government for me in the world should put this in their toolkit. That's my point in some sense. But sorry, you had other concerns.
So we also have done a bit of work using this nighttime lights at the ADB before. We try to use it to monitor economic activity. It doesn't go very well.
Why?
What the reason is because night lights data are usually a latent variable. It doesn't change over time very much. So during normal times, it does not really capture fluctuations in economic activity. But when we are using it to assess the impact of disasters, for example, it becomes very useful.
But it can be dangerous because I was looking at the Moroccan earthquake a few months ago, data from that, and in the places which were the most severely hit, nighttime luminosity went up because they had all the crews, the disaster relief crews were going in there and they had lights, right? But I mean, if you look, this is for the Gaza Strip. If you look at this is quarterly. That's quarterly.
Not aggregated annually?
No, this is quarterly data. This is quarterly data. No problem in terms of, and you can see the 2014 Gaza war there. That's what's highlighted there. 2014
Just
Gaza war.
last week, we had some discussion with the Indonesian National Economic Council on this. They also tried to use night lights to estimate the aggregate economic activity for a national basis. It does pretty well in terms of correlation, but in terms of accuracy, performance is actually pretty bad. And then at the end of the day, they have to correct a lot of things. And what ended up pushing up the accuracy of their estimates is the AR kind of component. So basically, night lights did contribute, but its contribution on the accuracy of the estimate is pretty low. But one of the other problem,
accuracy compared to what? What is the accurate measurement?
the root mean squared error for the estimation, basically. So if you compare the root mean squared error using night lights plus
Root mean squared error of what?
of estimate of the projection of the forecast.
Oh, forecast.
Yes.
Okay, but that's a forecast problem. It's not a data problem.
No, it's the within. So basically, you train the data with
Okay, so you're backcasting.
Yes, basically.
But you're backcasting. Okay.
Now,
Okay, I get it.
well, when you compare between the pure AR type of estimates and AR plus night lights, the additional accuracy improvements is really nothing. Basically,
It was small.
yeah, really
Okay,
small.
surprisingly.
One of the problems with Indonesia night lights figures is because Indonesia is a very diverse country with different economic activities. Right? So there are places like Java Island that has good, not good, high luminosity, basically, with high output. But there's also places where you have mining and forest, which also generate a lot of income, but has less luminosity than West Java. So one of the suggestion I gave to the youngsters in that office is that why don't you look at a probability of the correlation between luminosity and certain economic activity, because you can basically map this different economic activity into areas and then put it with night lights data. So what do you think of that? Would that work?
One, I think that would work. But two, my relation as a micro person, the reason is that I'm a micro person is that I've seen how GDP figures are constructed.
That's right.
And it's scary. I mean, I have a lot of trouble with GDP figures in general. I mean, I think it's basically garbage in, garbage out.
True, but
when people look at correlations in the cross section of countries, There's some very provocative papers. They look at a correlation in a cross-section of countries between GDP and NTL. One of the most significant variables which explains the difference between the two is autocratic governments.
I couldn't agree more on that, but what is the alternative? What alternative do we have? We have GDP figures from
we should. But I think we should. But I think how did the Italians calculate the size of the underground economy in the midst of George? So one of the ways they did it was through cement consumption, right? Cement and electricity. So I think we have to combine things, right? We have to be.
Yes.
We have to be.
There's also a paper that tries to estimate GDP in China using night lights, and
and I can tell you, it's a problem. I've worked on that actually.
Yeah.
I used to spend for 8 years. I used to spend a month and a half every summer at Renmin University in Beijing, and so we were looking at that exactly. And then one of my Chinese colleagues took me to a place, to a neighborhood outside in the outskirts of Beijing. There were 4-lane highways, rows of apartment, 25-story apartment buildings. Everything was illuminated. There was not a single person. Okay, so what we had to do to get the estimates to make sense is we got data from WeChat on communication. Okay, and so there we saw that these were ghost cities because there was no there was no communication, the standard Weibo and WeChat communication within those towers. And so we knew that was fake luminosity. I think you really have to combine, you have to be opportunistic. I agree with you. That's why I kept on saying, this is not a panacea.
I have a lot more questions, but I don't want to dominate things. So
We have 3 questions from online, and one also following the institutionalizing these usage of these tools as well. So please allow me to give them a room. So first one about disaster, the use of disaster of these tools. At the time of super typhoon, where satellite data may be compromised in terms of quality, can it also be integrated with data of, say, rising water levels of rivers while seeing the bird's eye views of particular urban area of megacity? This way, it's probably easier to track which area will have water spilling on lands first, if that makes sense.
It makes complete sense, but I must admit, I don't know anything about water levels and things like that. I'm the last person in the world you should have asked about that. But yes, I would. Why not? You have an answer to that? I'm sorry, I'm not there. I normally have an answer for everything there. I do not have an answer, but I would say it would be useful.
Okay, so Erica, if you have any further comments, by all means, please post it to me. I will make sure to pass it to Professor Arcand. Thank you for that question. So
this is Erica, just so she has my email is. Oops. Here.
yes,
You have my email there.
yes, you have his email. Yes, so please continue this conversation. We are very curious to learn from you as well. So the next one comes from Sorry if I pronounced your name wrongly. I have a question related to long-term study. We need to use both DMSP and VIIRS-NTR. Some studies were calibrated and make the consistent pixel size and image. However, I don't have the background knowledge to evaluate the output of these datasets. Did you recommend to download and use a dataset for policy evaluation in this case?
Yeah, I mean, you're absolutely right. I mean, this is the problem. There's this structural break in 2012. I'd stick to Black Marble. Honestly, I mean, that's it's cruel because one would like to be able to do things earlier, but I'd stick to Black Marble. It's state of the art as long as the Americans continue maintaining it.
Actually, this question from Stukunira I'm sorry for my pronunciation once again. Then thank you for your question. Why? So this is a very important question. Why is the application of remote sensing data in economics so slow? I suspect the most efficient way to promote its application in economics is to process them into spatial and temporal unit of analysis of economics. Channel data in smallest administrative boundaries. I have been using many remote sensing data since 2012, so that goes back to.
Well, his or her comment, it says something about how conservative economists are, right? We're very conservative people. We don't like changing our way of doing things. And it has to, and I think he or she is right. We have to package it, right? You would have to have it packaged as standard panel data that people can load into our data. Please load it into our data. But it's just a wink to open source community in the world. This is a question of marketing, and economists are very concerned. We're very conservative. Hopefully, there's some non-economists. Well, I know there are some non-economists in the room, but economists are very conservative about how we do things. I mean, let me just give you an example. How many people doing RCTs use randomization inference?
Most of us, we try to do that.
You do it, right? But there's a lot of people doing RCTs who they will not accept doing randomization inference, right? I mean, come on. I mean, this is something, right, that everyone should be doing. Economists tend to be really conservative. We take a lot of time to change our habits. I think that's the answer. So I think he or she has put his or her finger on something really important. If we want to expand the use of this sort of stuff, we have to provide it to the research community in a more user-friendly form, because it's not everyone who's going to want to learn quantum GIS and the integration of quantum GIS and Python to their R code. So geeks are going to like this, but if you want more people to use it, we have to make it user-friendly so that people can use it in Excel.
GGN is trying to do capacity building on this.
Yeah, I mean, it's an uphill battle. I have to find friendly governments. So far, I have been on as they said, this is a great idea. We want to do it. So they just went through elections, so they haven't done it yet. But hopefully, now that the elections are over, they will.
One last following question from Erica. So she would like to clarify her questions.
Yes.
So is satellite data compromising clarity with weather disturbance in the atmosphere?
Not if you average things over enough time, right? Sure, you can have days where the satellite can't see stuff, but you're not. If you want to use daily data, sure, right? But normally, there's not much in econ that people use where they use daily data, right? You aggregate it over a week or over a month or over a year. There, the satellite goes by for a sufficient number of times that just because there's been a typhoon, you lose those days. But anyway, you wouldn't want the days of the typhoon anyway in terms of nighttime luminosity. You'd want it a week later, or 2 weeks later, or 3 weeks later. What happens during the typhoon itself? Maybe you can't see things, but you can't see the lights. But who cares, right? If it's impacting economic activity, it's afterwards. But you have to be really careful. That's why I like the Gaza example, because you join the two together, right? And up until now, what geographers, they've looked at the impact of natural disasters. So when we were working with our geographer friends on the Gaza paper, they would have stopped at the destruction on the ground using the European Sentinel data. A geographer says that, okay, I know what the impact is of the conflict. It's, 80% of the houses in Khan Yunis have been destroyed. And they stop there. An economist then wants to convert that, right, into economic activity and not just the physical destruction, right? So I think they learned something from us there, right? They master the destruction data, of course, much better than we did. So we learned a lot from them. So associate yourselves with geographers. But the techniques for analyzing these data are the same, whether it's Black Marble or whether it's Sentinel. It's the same data.
Thank you, Professor. Thank you very much for the presentation. So I would like to know your opinion. I know that there's the old night timelines and then the new night timelines, and then there's a clear break between 2012, 13. But then I've been seeing in discussion in literature saying that there might be another shift happening, particularly due to the different types of lights.
Yeah, sure, of course.
So,
The street lights change.
Right.
Yeah. I don't know enough about the technology.
Yeah, so we're moving more towards the energy efficient.
Yeah, exactly.
LED,
Yeah.
and they're saying that these satellites are not really good at picking up these lights.
That's quite possible, but then this is what about GDP in terms of technological change? This is technological change. Of course, technological change is going to affect your measure. I remember all the debate. I'm old enough to remember these debates when I was a graduate student in the US, that in the, the baskets and the stuff that you pick up, IT wasn't in there, right? There are whole sectors which are not measured in GDP for a long time. So the measurement issue is something that economists tend to be really bad at. When you talk to when a political scientist gives a class on empirical methods or on what they call research design, right? We would call it an identification strategy. But a political scientist doing a PhD always takes a class in research design. They're really careful about data, right? They want data to be validated, right? There's a sort of a whole construction behind the data. Does it actually, is the measure, for them, everything is a proxy, right? Whereas we take things at face value, right? Come on. Achimambu Johnson Robinson, Protection Against Expropriation Risk by IRCB, by the International Risk Council, right? I mean, I have been an expert for them on risk assessments for countries in Africa. I get called up by those people who do the assessment of protection against expropriation risk in countries that I maybe visited last time was 10 years ago. And I'm going to give them an assessment of the protection against expropriation risk. And that's our measure of institutions, right? So again, measurement is a big issue, but I think it's a big issue with typical household surveys, right? Thank God now that we've got the bank and FAO and the whole group in Rome working on, updating LSMS and stuff like that, right? Even household surveys. I've run enough household surveys. I can tell you there are problems in household surveys measuring things. I don't think that the measurement problems are any less severe than, that's why don't oversell it, right? You shouldn't oversell MTL. But on the other hand, you should be aware that there are measurement problems with the stuff that we use on a daily basis. They're pretty scary. I remember once, and then I'll shut up. I was in the Gambia, and I was at the wonderfully named GBOS, the Gambia Bureau of Statistics. And when I look, GBOS, it sounds like something out of a mafia movie, right? Gambia is a little country. I was working on a randomization there, a World Bank program, which was the smallest program I've ever evaluated in terms of the value of the program. The loan was like a $12 million loan, but that was 2.5% of Gambia's GDP. Okay, so imagine a program in a country which is 2.5 of the GDP of the country, right? And I'm sitting there at GBOS, and I must confess I was smoking a cigarette outside. Okay, so I'm in a courtyard in GBOS. There's this big pile of rubble and papers, and there's an open window. And suddenly a bunch of paper comes flying out, and it lands in the middle of the courtyard. And I almost got hit by it. And then 2 minutes later, the same thing comes out. And I put my head in between the paper, the loads of paper flying out. And what are you guys doing? He said, classifying the national income statistics. And that's something that you do see. It's scary when you see how some national income statistics are constructed.
Well, I mean, President Arcand, I think you're very right. There are lots of, we really need to take data inference with lots of care, because all the data has now, even household consumption data, whenever I always look for some alternative way to proxy, like maybe housing quality and all that thing, because that's more accurate. It's more, you can see it visible. So like even the NTL data also has issues, but the thing that you really pointed out, I really value it in the sense that this is alternative data that you have, which you can use to confirm many things. And also in areas where we don't have data, actually it could help us to.
Yeah, that's it. I mean, we can't be more Catholic than the Pope,
yeah.
Right? I mean, it's as simple as that. And by the way, if you ask me what my favorite development indicator is, child anthropometrics. Weight for age and height for age. Those are my favorite development indicators. I think they're the most accurate. They're the most accurate because a baby wiggles. It's 0 to 60 months. A baby wiggles, but you can always weigh them and you can always measure them. And they're determined by household income, by access to basic sanitation and clean water, by maternal education, right? Maternal education, and by female empowerment. And we've known this for half a century, right? We've known this for half a century, and that's accurately measured. And we don't need a committee of the United Nations in New York, even if it's presided by someone as smart as Amartya Sen, to weigh various things to create a human development index. Mother Nature already does it in terms of child anthropometrics. It's a wonderful measure. I haven't done a survey in 20 years that has not included, I always include child anthropometrics. If you can't do that, MUAC, do mid-upper arm circumference. I mean, I remember doing a survey in Angola where there were landmines everywhere, so it was very difficult to get around. We couldn't transport the scales and the mess, so we did everything in MUAC. Works very nicely too.
So now I'd like to conclude this featured speaker series, and that we really learned a lot from you, Professor Arcand. So we really appreciate your visit, and also we are grateful to Global Development Network to give this opportunity. So we learned from your insight, we learned from your humbleness or openness to all the new tools and the innovative ideas. And above all, I think we learned your passion to really pursue new opportunities for inclusivity and democratizing what's possible in this planet. So thank you so much. So now I'd like to conclude, and thank you so much for joining us online and here in Tokyo. Thank you. If we have a reserve and we give a compliment.
Yeah, I mean, first, thank you very much. We are now with Bill working on the impact of decentralization in Indonesia to the economic performance. And one of the variables that now I'm looking for from Indonesian Bureau of Statistics is the nighttime light. And to my surprise, they already have the data, I think up to the district level. And we have more than 500 districts now. So I think nighttime data becomes like mainstream. Start slowly becoming the mainstream of the data, because I know that many people are frustrated with what you mentioned, the kind of sometimes inaccuracy of the data and difficulty to collect the data, especially if it is on the micro level. So I think it's a good idea to really bring this nighttime data into the mainstream.
And this is something where the global south can have actually a absolute advantage.
Yeah, because it's more accurate in developing country than in the advanced economy, right? Yeah.
Thank you for your inspiration. So now we formally conclude your session. Thank you.